We are taking letter C, and this is chapter number 7, the C preprocessor. Macros versus function. Macros and function, the key idea is same, but the functionality or the way they are taken care in C are different, or the compiler. Okay. First of all, they are like functions, but some differences there. When we find the macro, the lines in the macro, they are simply replaced. There is no passing of the control. But in function call, the control is passed to a function with certain arguments, or maybe no argument. Some calculation or operations are performed, and then we come back. This control is given back to your main program. So when to use macros and when to use a function, or you can say use macro with arguments. Macro with arguments is essentially equal to the function. Macro will make your program faster, it will but increase your program size, because hash defined preprocessing is very fast, but what you have after hash defined, that it will be replaced in your program, so that increases your program size. But the function will make your program smaller and compact. So if you use macro 100 times in a program, then 100 times or more, this any number of times, I'm just saying an example, 100 times, that source code will be replaced. Means that source code from the above hash defined line will be taken and will be placed inside your source code. That will increase your program size. But in function, this does not happen. Even if the function is called say 100 times different places, it will take the same amount of space in the program, because there is only one function you have made. There is only passing of the control. Okay. But when you talk about function, as we have learned about that, we transfer the control, and transferring the control and getting back, because we use stack there, we use various background activities. So this will make your program slow, and this gets avoided with macros, because this just expand and it will add to your source code before compilation. Okay. So what is the story moral? If the macro is simple and sweet, it makes our program, or you can see we have a shorthand here, and this avoids the overheads which are actually associated with function calls. As I suggested, we use stack there. But if we have a fairly say large macro, then and we want to use this very often, large macro is not advisable, so we need to replace it with the function. It's better to write function here. File inclusion. The second preprocessor directive here is file inclusion. File inclusion you might have seen up till now in your program, hash include file name. This you might have seen. So it is taking the file content, all file content, and actually it is replacing or putting that particular code from this file name inside your program. So if we have a very large program, the code is best divided into several different files. You cannot keep everything in one file. So it is good programming practice to keep different section of large program always separate. Separate means you want good cohesion and less coupling. So these files are included, hash included in your program. And there are certain functions and some macro definition that we would use or almost need in our program. These commonly functions and macro which are commonly used, this can be stored in a file. And now you include that file. Why to call it again and again? Call it into the file. So this will add all the statement in this file to our program. We don't need to type them again and again. So there is always a header file, and this header file is having the prototype for functions and macros prototype. Along with that, you have a library file where the content is there, where the definition is there. For example, in this math.h, you will find the prototypes of all the math functions. In conio.h, you will find the prototypes of all the input-output functions. So There exist two ways to include statement, hash include statement. First is by double quotes. This is file name with double quotes, and one is with the angle brackets. So these are the two ways in which or by which you can include these files inside your program. So what do they infer? What do they say? First is, if you include something with hash include, this command will look for the file, this one, goto.c here, in the current directory where you are, also along with all the specified list of directories you have mentioned in your include search path. If you have angle bracket, this command will look for the file goto.c here only in the specified list of directories. And this specified list of directories, if you are talking about Turbo C, C+ compiler, this you will specifically give in by selecting the directories and options, and all these files you give in that text box separated by the semicolon. So it will search in all the selected directory path, as well as if you use double quotes, it will search in the directories also, in the specified also, and where you are in that directory, and inside that directory also it will find, right? Conditional compilation. What if you want to skip some part? You have put some part and you want to skip that part. For that you might have learned about if-else construct. So this can be used like if def and if. This is the general form. Say you are trying to see the macro. If this is defined, then you will execute these three lines, otherwise not. This is the scenario. So if this macro name is defined, you have defined it somewhere, this block of code will work, otherwise it will not be worked. So where this if diff is useful, you want to comment out certain lines. For that you can use, because you have not defined that macro, and when you have not defined that, if defined for that macro will not execute. So you don't want to delete it, those lines, but you want to comment out. So rather than putting all the nested ones, have this nested comments, using this nested comment, this is the best idea. This is a solution which I wanted to convey. First is, if define OK, 1, 2, 3, 4 line will be executed, otherwise you will end up here. Just imagine a scenario where OK is not even being defined here. There is no OK. So when there is no OK, we have not defined this macro, these lines will never execute. And in some other point, after some days or week, you decide to run these lines, you just define this OK, or you just take off these lines or remove these lines. So these line will be run. So this is how if defined and end defined will work. There is one more sophisticated use of if def that will make your program portable, because your program is maybe going to be executed on Mac, Linux, various operating systems, or say some specific machine. So you can just put if defined Intel, you write this code for Intel PC, otherwise you write this code for PC. So this will make, if you have defined this Intel, this macro, it will run this, otherwise it will run Motorola PC. So this code will cater for Intel PC also and Motorola PC. I hope you got the idea. This will make your program portable, because now even if you use an Intel PC for your program or your Motorola PC, it is going to work. I hope you got the idea. There is one more thing which is called if not defined. This is simply the opposite of if defined. If and defined means if not defined. So if not defined this Intel, this code will be these line of code or whatever you have written here will be executed, otherwise this will be executed. So this is simply the opposite of if defined. Suppose you have a function my function which is defined in myfile.h, which is included in myfile1.h. Now if your program file, or in your program file, if you include this myfile.h and myfile1.h, you have this function, my function defined here also and here also. So the compiler will put a error, or it will flash an error that you have multiply defined my function, because this my file, same file myfile.h gets included twice. how to get rid of this or how to avoid this kind of situation. This is myfile.h. So you just say if not defined myfile.h underscore myfile. This is just the way of writing. You can write it in any way. If it is not defined, then you simply define it inside this and you come out. So if it is not defined, then you define, otherwise you will not do this. So this will avoid this scenario of multiple clashes or multiple function compiler flashing the error. This is how it is done. So you can just name it any way you want. If and elif directives. We have seen that if else we use, and this elif is used more specialized form of writing if else again and again. So this if directive can be used to test whether an expression evaluates to non-zero value or not. If the result of that expression is a non-zero, then the lines else, elif and if are going to be compiled, otherwise they will be skipped. I'll give you an example. If this is an expression, if test less than equal to 5, if it is less than equal to 5, then these 3 lines will be done, otherwise these 4 lines will be done and you end it. So this is a conditional if you are using. So this is checking for the condition now. Why we use in hash define? Because we want some hardware checking also. Say if adapter is VGA, video graphics adapter, or it is SVGA. So if adapter is VGA, these code you want to run. Otherwise, if it is SVGA, you want to run this, otherwise this one. If both are not there, this will be run. So now you have made it very open for all kind of graphics, and this program is going to work for all the graphics you have. Elif. Elif is again a very good form of making this if else this in a good way. Same program will write with elif. So in this elif, see, if adapter is equal to VGA, then this line, elif adapter is equal to SVGA, this line. So yeah, elif is just making your program more, you can say elegant and simple to understand. There are other directives also, like undef and pragma. What are these undef and pragma? Undef is undefined. There are various situations you might encounter where it may be desirable to cause a defined name to become undefined. You have already defined something. Now you want that to be undefined. For that, you use this undef directive. Say you have written a macro and you want to undefine it. Like undef macro and some name. So wherever this template will come, it will undefine. So undef Pentium means wherever this Pentium is being called or this Pentium is being defined, it will be undefined. This is what you have done. So this is seldom used, but you must know what undef means. When we come to pragma directive, this is again a special purpose directive when you want to turn off and turn on certain features. If there are certain programs, if you write in Microsoft C compiler, then there are certain listing and comments that the compiler will generate. Now you want to suppress the warnings which are generated by compiler. You are aware, you well in advance know that these kind of warnings are going to come. You want to suppress them. How to do that? This is done using your pragma. So this is pragma startup and pragma exit. So these directives, this allow us to specify the function that you want. Whenever the program starts up, something has to be done. Whenever you come out of the program, something has to be done. So I'll show you an example. This is a function 1, this is function 2. Now you say pragma start up function 1 and pragma exit function 2. So what this will do, when you go inside this main, first of all, you have just started up your program. So when you have started up the program, this function 1 has to be executed. So this line will come first. Function 1 will be executed. Now it goes to printf inside main, this is n. Then after that, when you are coming out of the function, this exit will run. So that this function will run. First this one, second this one, and third this one. This is startup and exit. So this will be the result. That is why you use this pragma startup and exit. Then you want to suppress some warnings. See, you have given here hash pragma warning RVL, return value. You have this parameter not used, and this is unreachable code. See in this program very carefully. First of all, we are passing this x in this function, and we are not utilizing it here. We have no x here inside this code. So we are not using this x. Okay. Here we have a function which is having a prototype, say it is returning something, but there is no return line here. There is no return line here. So this return error or return warning, parameter not used, this line and this code, see x++, this is after return. So this line will never be reached, because whenever you go inside this program, return will come here. Return will be executed, so you never reach this x++. So here is a scenario where this is a unreachable code. So all these three are here in this program when you call main. So the program or the compiler is going to give you the compiler warning, and you want to suppress it. So when you want to suppress it, you use these three lines. So this is the pragma warn. I hope you got the idea is F1 doesn't return a value, x which is passed to F2 is never used, and this F3 you have x++ after the return. So you get an error, and that error or your warning can be suppressed. If you put plus instead of minus here, if you use plus here, so the compiler is going to give you definitely give you the warning for these if you use plus here. So that is seldom used. I am just giving you an idea what this plus does, but this is seldom used. So let us summarize what we have seen. The preprocessor directive will enable us, you and me, to write programs that are quite easy to develop, read, modify and transport to different computer systems. There are various preprocessor directives like hash define, hash include, hash ifdef, hash else, hash undef, hash if, hash elif. We have special kind like undef and pragma, and these are used not very frequently, but you must know about them. So this is all about the preprocessor directive. Thank you so much and take care of yourself.